Notice, and this is the typical copyright. We continue with the mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. I am hoping to have for September 2024, that is this month, all 32 videos published from section 1, number theory and computation. And then in October, that's next month, consumer arithmetic and so on, sets, November, measurement, December to the end of the year. New year, January 2025, statistics. Then algebra in February. March, relations, functions, and graphs. April, geometry and trigonometry. And finally, hopefully by mid-May, vectors and matrices. Just a reminder that I have subdivided section 1 into 32 videos, which will all be made available on YouTube in their entirety. That is to say, the full videos. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you can deal with the rest of the syllabus. For the reminder, these 32 videos from section 1 cover the math schoolwork up to the end of Form 3, grade 9. That is over a 3-year period from Form 1 to Form 3. At this point, I can comfortably say that we have completed 16 videos, and this is now the 17th one. So we have completed everything on this list. We are now here, video 17 from objective 7. So objective 7, section 1, students should be able to state the value of a digit of a numeral in a given base. And then the further explanation is place value and the face value of numbers in bases 2, 4, 8, and 10. But we will do a general overview of bases so that any of the other bases you can also answer that question for. What you see up here is a print screen from your syllabus. We have divided this objective into 3 videos. Video 1, base 10. Video 2, which is this one, base 2. And video 3, the next one, will be bases 4 and 8. So we are here in base 2. If you find this video useful and interesting, please like and share. Like and share. And you may also consider subscribing to this channel. It doesn't cost you anything to subscribe, and it means a lot to me. So we continue. Note that this objective does not require you to manipulate numbers in base 2, just that you should be able to state the place and face values of such numbers or digits in a number in base 2. But we will still do a little addition and subtraction in base 2 so that you will understand better and especially remember longer. Now, base 2 has only 2 digits. Now, remember we said base 10 has 10 digits, 0 to 9. Well, base 2 has only 2 digits, and the 2 digits are 0 and 1. In other words, once you are working in base 2, those are the only 2 digits you can legitimately use. So let us say we have some stars to count and we have a grid system here. in this first position, we have 2 to the 0 power. Next one to the left is 2 to the first power. Next one to the left of that is 2 to the second power, and so on. So that this is 1, this is 2, this is 2 times 2, this is 2 times 2 times 2, and if we expand those in base 10, this is what we actually have. This first column has 1s, just like any other base. This second column has 2s, not 10, like in base 10. This third column has 4s, not hundreds, like in base 10, and so on, 8 and 16. Now remember, we are looking at the place values and of course the face values of digits in base 2. So if you count 1 star, 2 stars, you know we cannot write 2 in base 2. So we have to combine those two into a single group and put them over here. If we count some more stars, again, we cannot write 2, so we have to take those two and put them in a group over here. But that creates a problem here because now we have 2 and we cannot write 2, or we only have 0 and 1. So we will take those two, put them in one bigger group, and move them over here. So now we have one group of 2 of 2s. One group of 2 of 2. In base 2, that will be written as 1, 0, 0. If you don't look carefully to see that is base 2, you may be tempted to think that that means 100, which is so completely different because you don't have 100 stars. You only have 4. You have one group in this third position here, which is 4. If we keep counting stars, we get 2 more there. Then, of course, we have to take that 2 and create a new group here. We count some more, we get 2 more there. Now we have to take these 2 from here, carry it over here. But then we now have a problem here because we now have 2 in this group, but we can only have 1 since base 2 uses 0 and 1. We can't write 2. So we will take those 2, create a bigger group, and put them over here. Now this big group has 2 red groups, and the red group has 2 blue groups, and the blue group has 2 single stars. So that is how we get 2 of 2 of 2, which gives us that this place value is actually 8. So at this point, if you write 1, 0, 0, 0 in base 2, you mean that you have one group in this position, which actually contains only 8. If this were base 10, if it were base 10, that will be 1,000. In this position, you would have 1,000. But in base 2, in this position, you only have 8. Count some more stars, some more, and some more. We know how this works by now. We can't have 2 here, and then we can't have 2 here, and then we can't have 2 here. So now at this point, we have one group of 2 by 2 by 2 by 2. Let's look at that. One group of 2 green groups, and each green group has 2 red groups, and each red group has 2 blue groups, and each blue group has 2 stars. So we get 2 times 2 times 2 times 2. So this position here is actually 16s, or 2 to the 4th power, as you see up here. Let's count some more stars. We know by now once we get 2, we'll have to carry it over to the next group. So let's stop here. In base 10, how many stars do we have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 1, 23. We have 23 stars. That's in base 10. That is 2 groups of 10 and 3 single stars, if we were dealing with base 10. But in base 2, this number that we have here is written like this. 1, 0, 1, 1, 1. We have one group of 2 by 2 by 2 by 2. That's one group of 2 to the fourth. We have no group of 2 to the third. We have one group of 2 to the second. We have one group of 2 to the first, and we have a single star. So in base 2, that's 1, 0, 1, 1, 1. That's base 2. Let's do some binary addition, but first we will do some decimal addition to continue to make the point. If you had to add 89 and 35 in base 10, you know what you do. You add the 9 and the 5, you get 14. You cross off the 14 and put it down here. Actually, you are dividing by 10 and you get 1. That 1 goes over here, and this 4 goes down here, but you don't need to show this, and then you put the 4 here. That 1 goes over here. 8 and 1, 9, and 3, 12. This is more than 10. Well, it is more than 9. So you divide by 10 and you get 1, remainder 2. Well, we are working in base 10. So now you get 1 here and 2 down here. That 2 goes here. And this 1 goes over here in that hundreds position. No other 100 to add, so you bring it down. So notice that is what you do with base 10. Let's convert the base 10 numbers to base 1 and see what happens. 89. Now, these are the place values in base 2. 89 works out to be this. 164, no 32, 116, 18, and 11. If you add this 64, that 16, that 8, and that 1, you will get 89. Remember, we are dealing with place values. So let's put that number down here. And let's deal with the 35. 35 is actually a 32 plus a 2 plus a 1. So you have 1, no 16, no 8, no 4, 1, 2, and 1, 1. If you add all of that, 32 plus 2, 34, and 1, 35. You get 35 base 10. So now, let's add this in base 2. 1 and 1 is 2. But you know you cannot write 2. So if you divide that by 2, you get 1 up there and you get 0 down here. So this 0 goes here. Now, this is not a matter of just crossing out. You have to divide by the base. So you put a 0 here, and that 1 goes over here. 1 and 1 is 2, so basically the same thing happens. You take this 1 and carry it over here, and this 0 goes here. So now 1 and 0, bring that down. 1 and 0, bring that down. 1 and 0 is 1. 0 and 1 is 1. 1 and nothing to add there, you bring it down. So your answer is 1, 1, 1, 1, 1, 0, 0. So our answer is this. Put that over here. What do we have? We have 164, 132, 116, 18, 14, no 2, and no 1. Let's see how that works. This is 64 plus 32 plus 16 plus 8 plus 4 plus nothing else. That gives us 124, which means that this number here, 111100 in base 2 is the same as base 10. Let's try another number. If we add these, so we said base 2 has only 2 digits, 0 and 1. Now let's do a little binary subtraction. Now this is what you can do in subtraction. If you have this number in base 2 and you want to subtract this number in base 2, so normally you would say 1 from 0 can't go. So what do? You turn to the left and see if you have a digit in that space. In this place, so happen that we have 1. If we take that 1, from there we will now have no digit remaining, and we bring it over here, it becomes 2. Now in base 10, that will become 10. In base 8, that will become 8. In base 4, that will become 4. But we are dealing with base 2. So if you take 1 unit from the left and carry it to the right, you get 2 of the units on the right. So we get 2. 1 from 2 is 2. 1 from 0, here now, that can't work. So you come way over here, take that 1, and we get 2 here. Take 1 from that 2, remain with 1, and bring it over on the right. We get 2 there. Take 1 from this 2 and bring it 1 remaining and bring it over here. So now we have 2. So 1 from 2 is 1. 0 from 1 is 1. 1 from 0. 1 from 1 is 0. And you just bring down those digits there. So you get 1, 1, 0, 0, 1, 1, 1. So this part here about 2's complement and so on, you don't need to do that. I just went through that so you could understand a little more about place value. So now most CSEC IT students can breathe a sigh of relief. Don't need to do this anymore. So place value. We call that base 10 has 10 digits, 0 to 9. Other bases follow a similar pattern. Base 2 has only 2 digits, 0 and 1. Base 3 has 3 digits, 0, 1, and 2. And so on. Base 4, which we will do next, has 4 digits, 0, 1, 2, and 3. Base 5, and so on. Base 8 has 8 digits up to 7. Base 16 has 16 digits. Once you reach 9, this A will represent 10 and so on, so that F will represent 15. Note that the base itself is not one of the digits. 8 is not a digit in base 8, and neither is 2 in base 2. Now, in this objective, CSEC requires that you know just the place and face values of the digits of a numeral in base 2, base 4, base 8, and base 10. We are dealing now with base 2. So preview of bases, place values. In base 10, this first position here is 10 to the 0, and so on. We could go to the left. These are numbers bigger than 1, greater than 1, to the left that way. And then this way are fractions of 10. We do the same thing with base 2. You go this way. Place values greater than 1, place values less than 1, place values greater than 1 again. So if you have a digit in this point, it would be 4 to the 3rd power. And so on. Base 5, same thing. Follow the same pattern. 5 to the 0, 5 to the 1st, 5 to the 2nd, 5 to the 3rd, and so on. And if you come to the right of that, 5 to the -1, -2, -3. Base 12, same pattern. Base 15, same pattern. Notice that if you go from right to left, each one increases by a power of that base. So let's just look at base 10 again. Base 10, we saw that a little while ago, but now we will put in the numbers 1, 10, 100, and so on. So if you have a number like 4,547.842, like this, notice this 4 is in this 1,000 position, which is the same as 10 to the 3rd. So its place value, that 4, its place value is in 1,000 place. And what is its face value? its face value is 4. So you have 4 in the 1000 position. That gives you 4000. This 7 is 7 in the ones position. So 7 ones. How many ones? 7. So the face value is 7 and the position is 1. This 4, for example, here, this 4 now, this one, is in the 100 position. That is its place value. 10 to the negative 2. And how many do you have? You have 4 of those. So its face value is 4 and its place value is 100 position. That is for base 10. Base 2 follow the same pattern. Place value that we can see here, and these are the decimal equivalent. If we take a number like 1101.101 and we write it in here, this one is in this place here, 2 to the second power, which is 4. This one is at this place here, 1, 8. And how many of this do we have? We only have 1. Because remember, in base 2, you could either have 0 or 1. You can't have more than that. Whereas in base 10, you could have 8 and you could have 9. So if we look at this number, if we want to carry it to base 10, it will be 8, because this we have 1 in the 8th position, plus 4, we have 1 in the 4th position, nothing in the 2nd position, so nothing there. We have 1 in the 1's position, so that's plus 1. We have 1 in the half position, so plus half. We have nothing in the quarter position, this position, so nothing there. And we have 1 in this position, so that would be 1/8. So if you add 8 and 4 and 1 and half and 1/8, you will get the decimal, the base 10 equivalent of this number here that we just wrote in base 2. Now, place value is defined as the position that a digit occupies in a number. Consider this number in base 10. This 7, what position is it in? We know that's 1, 10, hundreds. So that 7 position is in the hundreds position. That's the place value. This 2, what position is that? It's in the 1/10 position. So that is its place value. Now remember, all we need to know is the face and place values. Now what is the face value? Face value is the actual value of the digit that you see. Its face value is 7. So you have 7 in the hundreds position, that means 7 hundreds. And you have 2 in the 1/10 position, that actually means 2/10. So both face and place values are needed to determine what a digit means in a number. Back to base 2, this time without a grid, we will just write in the place values. So this is what it looks like. Notice here, 2 to the 0, you go that way, you increase the index by 1 every time you step over to the next place, and over here, you decrease it by 1. So this position here is 1, next position is 2, next position is 4, 8, and so on, 16, 32, 64, and so on. That is to say, if you expand 2 to the 8, you will get 256. So that's the place value. Over here, you go down half, quarter, 1/8, 1/16, and so on. So let's consider this example. You have a binary number here, and we will consider this digit. Where in the scale up here is it placed? Well, if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, that means, remember you have a 0 here. That means it's 2 to the 8. So it is actually here. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 2 to the 8 power. So the place value of this 1 is 2 to the 8, or in this 256 position. A is in the position 2 to the 8 in base 10, that is 256. Let's take this digit, 1, 2, 3, 4, 1, 2, 3, 4. So it's here. It's in the 2 to the 3rd position, which is in the 8th position. But since we have 0 of it, it has no value, 0. Take one more example. This one here, if we count from the ones, well, this would be 1, 2, 3, 4, 5. That will be 2 to the 4th position, because remember, there is this 0 here. So 2 to the 4th, 2 to the 4th, which is here. 2 to the 4th, and we get one of those, which will take us to 16 in base 10. And this one here, this is -1, -2, -3, -4. So it's 1 over 2 to the 4th power, which will take us here. And we have one of those. So 2 to the -4 power, which would give us 1/16. So for this objective, you are required to state the value of a digit of a numeral in a given base, and the base we were looking at was base 2. We now know what place value is and what face value is. So we just did this. Place value and face value of digits in base 2. That was base 2 that we just did. And that brings us to the end of this video on bases, and we looked at base 2 from objective 7 in section 1.